So in this video, we're going to have a quick look at what sigma notation is, and then we're going to use it for a series of simple problems. So if you ever see this notation, well, it's the Greek letter sigma, it's the capital sigma. And all that this means is that we need to add together all of the terms in the form f of r, starting when r is equal to 1, or whatever this bottom value is, going up to r is equal to n, or whatever the top value is, depending on the question. And that's all sigma means. Sigma is just a summation, so it just means you need to add up all of your terms. So let's just see this for a series of simple problems then. So in part A, it says write down all the terms of the following series and evaluate the series. So we've got sigma of 2r squared, where r is equal to 1, up to r is equal to 6. So we can say, right, well, first of all, we've got our function 2r squared, and we're substituting in r is equal to 1. So we have 2 times 1 squared plus 2 times our next r value, which is 2. We're going up in integers. So we've got 2 times 2 squared plus 2 times our next r value, which is 3 squared, plus 2 times our next r value, which is 4 squared, plus 2 times our next value, which is 5 squared, plus 2 times our next r value, which is 6 squared. And that's all that notation really means. Okay, where we're going from r equals 1 all the way up to r is equal to 6. And because it's representing a series, they are going up in integer values. So let's simplify this then. First term is 2 plus 8 plus 18 plus 32 plus 50 plus 72, which if you add these together, 18 plus 32 is 50, plus another 50 is 100, plus 10, 110, plus 72 gives us 182. And that's what we get for the summation of 2r squared between r equals 1 up to r equals 6. Let's do a similar idea with part B then. We're given the summation of 1 over k times k plus 1, where k is equal to 1 up to k equals 5. So for this one, we've got 1 over 1 times 1 plus 1, which is 2, plus 1 over our next k value, which is 2. 2 plus 1 is 3, plus 1 over our next k value is 3. 3 plus 1 is 4, plus 1 over our next k value is 4. 4 plus 1 is 5, plus our next k value is 5. 5 plus 1 is equal to 6. Let's simplify those denominators. So we've got 1 over 2 plus 1 over 6 plus 1 over 12 plus 1 over 20 plus 1 over 30, which if you put those together gets you 5 over 6. Okay, so that's what we get for the summation of 1 over k times k plus 1 between k equals 1 up to k equals 5. Similar idea again with part C. This time we've got n as our variable, but this time our starting n value is 3. So we don't care about n equals 1 or 2. Our starting value is n equals 3, and we're going up to an n value of 10. So we have 1 over 3 plus 1, which is 4, 3 minus 2, which is 1, plus 1 over our next n value is 4. So 4 plus 1 is 5, and 4 minus 2 is 2, plus 1 over our next n value is 5. 5 plus 1 is 6, 5 minus 2 is 3, plus 1 over our next n value is 6. 6 plus 1 is 7. 6 minus 2 is 4, plus 1 over our next n value is 7. 7 plus 1 is 8. 7 minus 2 is 5, plus 1 over 8 plus 1 is 9, 8 minus 2 is 6, plus 1 over 9 plus 1 is 10, 9 minus 2 is 7, plus 1 over 10 plus 1 is 11, and 10 minus 2 is 8. So it's a little bit longer, this one. So if we simplify those denominators, we've got a quarter, plus 1 over 10, plus 1 over 18, plus 1 over 28, plus 1 over 40, plus 1 over 54, plus 1 over 70, plus 1 over 88. And when you combine all of those together, you end up with 758 over 1,435. It's not quite as nice as the other two, but it's just using the same idea. The only difference this time is we started with an n value of 3 instead of starting with a k or an r value of 1. But that's the basic idea of what sigma notation means.